So in chapter 9, we're going to be focusing on the trigonometric identities. So on the Trig cheat sheet, so most of the relevant trigonometric identities we're going to use are located on the second page. So in so in section 9.1, we're going to focus on the first three sets here on the left column. So the tangent and cotangent identities, the reciprocal identities, and the Pythagorean identities, right? So section 9.1 is on this set here. Section 9.2, if I remember, is the sum and difference formulas. So that's this here. And then section 9.3 is the double and half angle formula. So the double angle formula is here. The half angle formula is here. And so probably we don't do the sum to product formulas. Okay, so and then 9.5 is on solving equations, but again, mostly using the identities here. Okay, so today we're going to focus on, again, these particular identities here. So in the first page of the section 9.1 worksheet, it's just basically explaining where these particular identities come from, right? So in as for the reciprocal identities, they're just basically coming from the formulas given by the unit circle, right? So you can see that if you compare sine and cosecant, right? So sine is y over 1, whereas cosecant is 1 over y. And so the two formulas themselves are just reciprocals of each other. And then similarly for cosine and secant, and then tangent versus cotangent, right? So in terms of their formulas, they're just reciprocals of each other. So so that's where the reciprocal identities come from. Right? So secant is the reciprocal of cosine, cosecant is the reciprocal of sine, and then cotangent is the reciprocal of cotangent. And additionally, you can see the relationship between sine, cosine, and tangent, right? So the formula for tangent is y over x, but y is just sine, and then x is just cosine, right? So that means that tangent has to be sine over cosine. So that's where that formula comes from. So basically, the tangent and cotangent identities and the reciprocal identities, right? So the two sets here, again, are just coming from the unit circle definition of the trig functions. And we use the unit circle definition here, but it's exactly the same for the right triangle, right? So if you compare the opposite, hypotenuse, and adjacent formulations for the trig functions, they have exactly the same relationship. Okay, so so that's where these identities come from. In terms of how they're used, typically when we're working with identities, most of the times we want to reduce everything in terms of sine and cosine because those are the two main trig functions, right? So so I mean, first of all, if you see cosecant, secant, and cotangent, typically you want to use these identities to write them in terms of sine, cosine, and tangent, and then tangent in terms can be again written in terms of sine and cosine, right? So the usage of these identities typically is to reduce everything to being written in terms of sine and cosine. Okay, so those are those basic trig identities. And one thing about notation is when we get to the Pythagorean identities, you can see that we starting to have powers of the trig functions, right? So here you have sine squared, but how you think of the powers, you want to be very careful about that, right? So when we write like sine squared like this, where the power is with the function, the way you should think of this is that the whole sine function is being squared, right? So what that means is like, say I give you an angle, like 30 degrees or something. The way you would calculate it is to first take the sine of 30 degrees, that happens to be 1/2, and then the result of that is being squared. So that's what this expression means. What it doesn't mean is that the power does not apply to the angle, right? So this is something completely different. Whereas the way you do this calculation is you square the angle first, whatever that turns out to be, and then you apply the sine function to that angle, right? So these two things are different, and when you see when we write it like this, it actually means this particular way to write it instead of this. This is completely different, and then this is very rarely used, right? So most of the times when we have powers, this is what we mean.
Professor Val?
Yes.
Can you just write out an example real quick so that way I can make sure that what I'm thinking is the same thing that you're saying?
Yeah. So let's say okay. So I'm gonna work in radians because again that's let me okay. So let me write it down here. So we have a little bit of space, right? So so like say I want to calculate sine squared of pi over 6. So what this means is, again, the power is being applied to the entire function like this, right? So I would write it out like sine pi over 6, and then this thing squared. So in terms of the order of operations, you always do the thing inside the parentheses first, right? So so what does this come out to be? Well, so you do sine of, make sure I'm in radian mode, right? So sine pi over 6. This is a special angle, right? So it's just going to come out to be 1/2. Right, so sine of pi over 6 is 1/2. And then the result of that is being squared. Right, so 1/2 squared would be 1/4. Okay, so that's that. Whereas if I write out sine pi over 6 squared like this, right? So again, you follow the order of operations where the pi over 6 is being squared first, and then the sine is being applied to the result of that, right? So this would mean sine of pi squared over 36, right? So this part is being squared first, and then and then now we do the calculation. It's a sine pi squared over 36. And if I calculate this, it's something completely different, right? So 0.2707. Okay, so these two things are not the same.
Thank you.
Yeah, so that's, and then so be careful about how you think of the powers of the trig functions, right? So they when we have powers of the trig functions, we typically almost always mean the first thing that I've written here, right? So this expression. So like, I mean, really, what does it mean to square something? It means that you multiply that thing by itself, right? So this thing would be sine of theta times sine of theta. Whereas this thing means sine of theta times theta. Okay, so again, these two things are these two things are different.
Thank you, Professor Bell.
Okay, so so in terms of the Pythagorean identities, I mean the reason it's called the Pythagorean identity is exactly because it comes from the Pythagorean theorem and right triangles, right? So if you draw in a right triangle with hypotenuse 1, right, and then the two sides are x and y, so that's exactly how you fit in a right triangle into the unit circle, right? So this kind of right triangle, and then if you write out the Pythagorean theorem, it's just y squared plus x squared is equal to 1, right? So this squared plus this squared is equal to the hypotenuse squared. But then y and x for the unit circle is just sine and cosine, right? So y squared is just sine squared, and then x squared is just cosine squared, and then again, when you write sine squared like this, the shorthand way to do it is to put the power with the sine part, right? So this is where this Pythagorean identity is coming from. So that's the first one. The first one here, right? So sine squared plus cosine squared is equal to 1. And then the other two Pythagorean identities are just coming from the main one, right? Because as I say, the sine and cosine are the two main trig functions. The other ones are just derived from sine and cosine, right? So if you take this equation and you divide everything by cosine squared, right? So this thing divided by cosine squared, this thing divided by cosine squared, and then this thing divided by cosine squared, then it produces this identity, right? Because sine over cosine is the same as tangent. Cosine over cosine just cancels out because you're dividing something by itself, right? So that's just 1. And then 1 over cosine is the same thing as secant. So that's where this formula comes from. And then if you do the same thing and you divide by sine squared, then you get the other Pythagorean identities. Right, so basically, these two are just derived from the first one by the relationship between sine, cosine, and the other trig functions. Okay, so that's the Pythagorean identity, and what the Pythagorean identity essentially is saying is that no matter what angle theta you take, if you plug it into this formula, it will always calculate to be 1, right? So for example, I do sine squared of, so let's just choose some random angle, right? So it's like, say, 27 degrees plus cosine squared 27 degrees, right? So I mean, sine of 27 degrees is going to be like point something something, like 0.4 something maybe, right? And then cosine of 27 degrees is going to be I don't even know, like 0.7 something maybe, right? So it's some long decimal number, and then if you square sine and then you square cosine and then you add them together, they'll always be equal to 1, right? So we can check that, right? So here I've written it in degrees, right? So before I was working in radians, so let's make sure I'm working in degrees now, right? Degrees, right? So you see how sine of 27 degrees is some long decimal number. Cosine of 27 degrees also is some long decimal number, right? But now, if I do, so the first one squared plus the second one squared is a 0.439904997 squared plus
Professor,
0.8910065242 squared, right?
Professor,
So the sine squared plus the result of the sine squared plus the result of the cosine squared. It's not going to be exactly 1 because I'm approximating here, right? Because I'm using the decimal approximation. So you can see that, I mean, it should be equal to 1, but it's being approximated. So it's just some number that's very close to 1.
Professor.
Yes.
Yeah. You can copy paste the answer calculate.
Yeah. I can. Yeah, I didn't have to type it out like that. No, that's not what I want. Okay, I mean, I didn't have to. I could just type the whole function in, right? So sine of 27 squared, right? So as I said, when you square the trig function, you should really think of it like this, right? So and then plus cosine. Oops, I need the extra parentheses. Cosine 27 close squared, right? So sine squared plus cosine squared. Now it's exactly equal to 1 because now I'm not approximating. And again, this is true no matter what angle you try to calculate this with. So that's what this identity is saying. Again, it's essentially coming from this right triangle with hypotenuse 1. Okay, so those are the Pythagorean identities. So and any questions on the identities?